Welcome to today's explainer. I am absolutely thrilled to dive into this one because we are looking at a ridiculously simple 5-word phrase that completely transforms how AI reasoning works. If you've spent any time tinkering with large language models, you know exactly what I'm talking about here. You've probably experienced that incredibly common, widespread frustration. I mean, you've likely seen an AI write this brilliant, highly complex block of code or instantly generate a beautiful Shakespearean sonnet, only to completely and totally faceplant when you ask it a basic logical or math question. Right? It's a bizarre paradox with this technology. But today we're unpacking a fascinating breakthrough technique called Zero-Shot CoT prompting. And listen, this isn't just some clever formatting trick. It's actually a profound window into how these models retrieve and process their pre-trained knowledge, and it fixes that logic gap instantly. Let's dive right in.
Okay, so let's start with a classic middle school math problem to really illustrate this. Say, if John has 5 pears, then eats 2 and buys 5 more, then gives 3 to his friend, how many pears does he have? Now, to us humans, this is super straightforward, right? Just basic addition and subtraction. But we really need to understand why standard large language models historically fail at this exact kind of thing. You see, these models aren't calculators. They don't have built-in memory registers holding variables and tracking state changes over time. Instead, they're essentially just highly advanced autocomplete engines. They are constantly just predicting the statistically most likely next token. So when you ask a multi-step question and force the model to immediately jump to the final number in one single massive leap, well, its statistical map just breaks down, and that leads to a highly confident but entirely incorrect guess.
And this perfectly illustrates what happens. The standard AI output instantly jumps to the conclusion, and it confidently gets it wrong, telling us John has 8 pears. The statistical prediction completely missed the mark, because the cognitive leap was just too far. But look what happens when we applied our zero-shot chain of thought prompting on the right. The model's behavior completely shifts. It's like it literally slows down. Instead of just wildly guessing, it actually writes out its internal monologue. It says John starts with 5 pears. He eats 2, leaving him with 3. He buys 5 more, giving him a total of 8. He gives 3 to his friend, leaving him with only 5 pears. By outputting the text, the model is using its own generated words as an external memory scratchpad. It's maintaining the state in the text itself, mapping out this perfect logical sequence to arrive at the correct answer.
Now, what's really wild here is how this massive leap in AI performance was unlocked in the first place. A research team led by Kojima achieved all of this by simply appending these exact 5 words to the end of a user's prompt. Let's think step by step. Seriously, that's it. That single sentence completely overrides the model's instinct to just guess the final outcome. And by appending this phrase, you aren't just giving it a polite suggestion. You are fundamentally shifting the model's internal processing. Instead of operating in a direct answer state, the prompt forces the AI into a procedural generation state. It acts as a strict syntactic trigger that literally forces the language model to methodically narrate its internal reasoning before it is even mathematically capable of outputting the final answer. To truly grasp why this is such a major, game-changing breakthrough for developers and prompt engineers, we have to talk about the zero-shot element. Before this, to get an AI to reason effectively, developers relied on traditional few-shot chain of thought. And honestly, it was incredibly tedious. It required you to painstakingly handcraft multiple, highly complex reasoning examples, what we call exemplars, and feed them to the model to explicitly teach it how to think for every specific type of task. It was a ton of work. Zero-shot eliminates all of that manual labor. By just appending our magic phrase, the AI taps directly into the latent logic and reasoning patterns already buried deep within its pre-trained weights. It generates the reasoning entirely on its own, without needing a single pre-written example from you.
Now you might be wondering, did the researchers just magically guess this exact phrase on the first try? Definitely not. They actually tested a few different variations to see how the models would react. They tried out prompts like, let's solve this problem by splitting it into steps, and let's think about this logically. So why didn't telling the AI to just think logically work as well? Well, it turns out the word logically is simply too abstract for a language model. It just doesn't provide a concrete structural template for the output. The crucial point here is that the specific phrase, let's think step by step, acts as a definitive syntactic trigger. It practically forces the model's attention mechanism to generate a sequentially numbered or bulleted list of thoughts, which organizes its processing power in the absolute most optimal way possible.
Let's move along and see how this actually runs under the hood. It's actually this really clever 2-step dance. Step 1 is where the AI receives your original query, appended with our magic phrase, and it generates all that long-form reasoning, mapping out every single detail of the problem. But
But here's the catch. If you're building an application, you usually just want the final value, right? You don't want a massive paragraph of text. And that is exactly where step 2 comes in, the extraction phase. A second follow-up prompt, something along the lines of, therefore, the final answer is seamlessly appended to the end of the AI's own generated text. The model then reads its own reasoning and cleanly pulls out just the final value. This self-augmented pipeline ensures you get accurate, structured data without you having to manually parse through a giant wall of logic.
So what does this all mean for your everyday workflow? Well, this specific prompting technique excels dramatically across 3 core logic areas: arithmetic, common sense reasoning, and symbolic reasoning. Take symbolic reasoning, for example. Imagine asking an AI to take the final letter of 5 different, completely random words and concatenate them into a brand new, made-up word. Standard models usually scramble this completely. But with zero-shot chain of thought, the model systematically lists each word, isolates every final letter on a new line, and combines them flawlessly at the very end. It instantly elevates the model's reliability in highly technical areas, especially when writing out manual examples is just too difficult or incredibly time-consuming.
But wait, here is a totally surprising and fun fact you probably wouldn't expect. We've been focusing super heavily on math and strict logic so far, but this technique actually crosses right over into creativity. It's known as the frog and mushroom effect. If you use this exact phrase on a prompt asking for a story about a frog and a mushroom who become unlikely friends in a magical forest, it actually supercharges the output. By forcing the AI to think step by step, the model systematically plans out all the narrative beats. It outlines the character motivations, establishes the setting, and creates a logical plot structure before it ever begins writing the actual prose. The end result is a significantly richer, deeper, and way more emotionally coherent story generation than a standard prompt could ever hope to achieve.
However, let's be real for a second, it's not absolute magic. It is really vital to understand the technical limitations if you are building workflows with this. For highly complex, domain-specific tasks, I'm talking things like advanced legal analysis or intricate medical diagnostics. Zero-shot just won't cut it. You are still going to need those traditional handcrafted examples. Furthermore, that clever 2-step extraction process we just talked about, it can sometimes get surprisingly messy. Occasionally, the model's reasoning drifts off topic, or the context window gets so clogged up with its own long-winded internal logic that it completely loses the thread of the original question. And that can cause the extraction step to fail, making the whole pipeline a bit less generalizable across all production environments than it might initially appear.
Which leaves us with this really provocative thought to take away from our explainer today. If 5 simple words can unlock an AI's hidden reasoning, what other simple phrases are we completely missing? The field of prompt engineering is constantly evolving, and it proves time and time again that it's just as much an art of human psychology and linguistics as it is strict computer science. Sometimes the absolute biggest leaps in AI capability don't come from massive, billion-dollar computational upgrades, but from the most elegant, simple linguistic tweaks that just happen to speak the model's language perfectly. This completely opens the door for you to experiment with your own hidden prompts in your workflows. Try it out! Thank you so much for joining me for this explainer, and I will see you in the next one.